So if you notice, look at this precipitate. Now it's on the bottom, right? So to prove you that the precipitate actually formed on the bottom, we're going to filter it out. So here I have a funnel with the flask. And the flask is best used with the funnels to filter something. And of course I have the filter paper right here. And to use the filter paper, you fold this into four. And now you have yourself somewhat look like a funnel, isn't it? Isn't that beautiful? Okay, so this is going to be used to collect the solid that's produced in the chemical reaction, which specifically chalk. So I'm going to pour this in, okay? And we're going to come back to this later in the reaction. And notice how, if we look on the bottom right here, so right there, it starts dripping right there, on the bottom right there. That's because the water has gone through the filter paper, leaving behind the solid precipitate, which is chalk. And other substances that are smaller than chalk will of course also filter down as well. And you can see that right there. Notice how the water is a lot clearer. See that? So we're going to get back to that later. Now let's try some other problems that relate to this chemical reaction. Okay, so again the concept is the same thing, just keep in mind the coefficient. If there's nothing there, the coefficient is 1. And this is a balanced chemical equation. So this only works if you have a balanced chemical equation, okay? So keep that in mind. Let's look at this problem. Using your stoichiometry flowchart, determine how many moles of chalk. Ooh, we're looking for mole now. And we are given the molar mass, of course, will be produced from 3.7 grams of calcium chloride. With the molar mass of calcium chloride, reacting with excess amount of sodium carbonate. Again, we can ignore the term excess amount because it doesn't tell us how much product we're going to make. In this case, of course, we are looking for mole of chalk. So we are question mark of mole of chalk, which is CaCO3, okay? And we are starting from, notice we are starting from 3.7 grams of calcium chloride. So that is our given, which is 3.7 grams of CaCO2. And of course we can ignore the excess amount of that. Now let's go back to our flowchart. And again, we are dealing with two different chemicals. The given chemicals is CaCO2, and we are looking for CaCO3. So let's label this chemical A because we always start in size A. And this is our chemical B, okay? But in this case, we are starting from the same place just by coincidence, okay, which is grams of A, which is right here. So we start. And that's where our grams of A is. But we are not stopping at grams of B like in the other problem because our unknown, which is moles of calcium carbonate. So we are looking for moles of calcium carbonate. So we go to side B, okay? Not side A anymore, but now side B because we deal with chemical, not the same as your given. So look at mole B, which is right here. There's nowhere else that has mole B. So this is where we are going to end. So let's trace back our flowchart. And we're starting from here to there. We cannot just go down here directly. It doesn't work like that, right? So we have to go down. That's our first conversion factor. And we go across. And that is our second conversion factor. And these are the conversion factors that our given has to multiply by to get to moles of B, which is moles of calcium carbonate. Okay, so let's show the work. So I have that right there, just in case, okay? This is for the mole ratio right there. Because we're going to use that conversion factor, we need the mole ratio. Let's go back to our flowchart. So of course we always use this format, okay? We are looking for what? Moles of calcium carbonate. But we are starting from this much of calcium chloride. So we are given 3.7 grams of calcium chloride. And to get from here, which is mass of A, to there, we multiply by that conversion factor first, which is 1 moles of A. And I know what A is going to be is calcium chloride, equal to the number of grams of A, and we call this, remember, molar mass, which is 111 grams per mole. So that number of grams is 111 grams of calcium chloride. See how that works? That's the name for molar mass. And this conversion factor name is molar mass. That's why it's important that we need to understand that it has a specific name to it. That's why it's important to understand that this has a name to it. Now we're moving on to the second conversion factor, which is the number of moles A and the number of moles B. And remember, this is called a mole ratio conversion factor. And A, again, let's just write out number of moles A, which is calcium chloride, okay, equal to the number of mole B. And we know B is your substance that we are looking for, which is calcium carbonate, okay. But where do we get this number from? That number is your coefficient or the subscript. Well, in this case, we deal with chemical reaction. We are looking at the coefficient. And what is the coefficient for it? Let's go back. This is the coefficient of a balanced chemical equation. So for calcium chloride, which is right here, what's the coefficient? It's 1, okay? And what about the coefficient for B, which is calcium carbonate? It's 1 as well. It doesn't have to be always 1. It's based on your balanced chemical equation, okay? So keep that in mind. Now let's rewrite this as a fraction. So we have 3.7 grams of CaCO2 time. See, notice how this is grams of calcium carbonate. Notice how this is gram of calcium chloride. So we look at the conversion factor we multiply to. We have mole and gram. Of course, we want to cancel the grams so we can move on to the next one. So the grams going to be on the bottom, calcium chloride. And what's on top? Of course, is your moles of calcium chloride. Notice how grams of calcium chloride, and now we have mole. Okay, and we are done with this conversion factor. Let's move on to the next one. So we multiply to the next conversion factor. Notice how I have moles of calcium chloride, and look at the conversion factor. I have moles of calcium chloride equal to the moles of calcium carbonate. So to cancel that, this calcium chloride has to be on the bottom. So if that's on the bottom, the other part must be on top. And that cancels out, giving us nothing else left to multiply. Giving us our moles of calcium carbonate, which is exactly what we're looking for, right? Now let's rewrite it so that we multiply everything on top, divide everything on the bottom. So on top we have 3.7 times 1 times 1, so we can ignore that. But look at this, we have moles of calcium carbonate, so we can say that mole of calcium carbonate. Why don't I write the 1? Because anything multiplied by 1 is equal to self. And then divide everything on the bottom, which is just 111 times 1. So we have 111. And that is our answer. And if we use a calculator, just plug it in. And we have 3.7 divided by 111. Give us 0.033 moles of calcium carbonate. So if we starting with 3.7 grams of calcium chloride, and that is how much calcium carbonate in moles that we will produce, okay? And that's the concept behind it. Ready to try another problems? Here we have the same chemical reaction, right? Why am I using the chemical reaction? Because I want you to realize that one problem can be, or one chemical reaction can be written in many different problems. And the complexity of the problem is not that complicated at all if you know how to use it, right? Always identify your given unit and the chemical, and what are you looking for? Is it the same chemical? If it's the same, we say on side A. Is it a different chemical? Then we go to side B. So the same situation, we have a balanced chemical equation. Now let's read the problem. So to make 370.37 grams of chalk calcium carbonate, okay, and given the molar mass of calcium carbonate from the chemical reaction above, which is that one, and we're balanced already. It has to be balanced, okay? We need to react 3.7 mole of calcium chloride with excess amounts of sodium carbonate, and we have the molar mass as well. And the question asks us how many grams of calcium chloride are needed from the chemical reaction. So this is our unknown. We are looking for how many grams, okay? So question mark is grams of calcium chloride. And what is given to us? We have to read this really carefully. We are given two things. We are given the grams of chalk, which is given grams of chalk, 370.3 grams. That's our given number one, okay? But we're also given something in calcium chloride as well. Look at that. Look at right here. We are react with 3.7 moles of calcium chloride. So that is our given number 2. So this problem becomes even more complicated because we don't know which given to use. Now let's use our common sense if we look at our flowchart. Would you like to go from grams of A all the way to grams of B? Or would you like to stay from grams of A, or in this case, it's not grams of A, but moles of A, because we are given 3.7 moles of calcium chloride, right? Moles of A, okay? And we are going to solve for grams of A from here to there. So again, we have 2 given. One is in grams of A, right there, calcium carbonate. That is completely different than calcium chloride, so that makes it into a B, okay? So using given number 1, we have to start from calcium carbonate, which is A, all the way to a different chemical, which is calcium chloride. But we can use the second given right here, which just happened to be 3.7 moles of calcium chloride. Notice how they are the same chemical, right? So we can just focus on size A. So we have mole going all the way to A of grams. Which is easier? Of course this one's easier. So don't get tricked by the problem. And they both give you the right answer. It doesn't matter what. So we are starting, if we use our given interval 3.7 moles of calcium chloride, we are starting here. And where do we end? Of course, grams of calcium chloride. This is where we end. So to get from here to there, we just need to go up by 1 and multiply that conversion factor. Isn't that easy? Okay, so let's do it. So let's do this problem. So our given is, well, of course we are looking for question mark grams of CaCO2 equal to, what's our given? 3.7 mole of CaCO2. And we start right here, mole, and we go up, which is 1 conversion factor. And that is 1 moles of A in this case is calcium chloride, equal to the number of grams of A, which is the molar mass. And what's the molar mass of calcium chloride? Oh, 111 grams of CaCO2. And then we are done. We just have to rewrite this as a fraction. 3.7 mole CaCO2 times, what's on the bottom? And this is moles of CaCO2. The bottom part would be 1 moles of CaCO2. That cancels out. What's on top? Of course the leftover, grams of CaCO2. And that cancels out with this one, right? And we just multiply everything on top, divide everything on the bottom, which is 3.7 times 111 grams of CaCO2. Divide anything on the bottom? No, because it's just 1. So let's plug this into our calculator. So 3.7 times 11. So 3.7 times 111. And giving us 410.7 grams of CaCO2. So what does that tell you? This is how much you will need into a calcium chloride to make that much amount of chalk. But it is also mean that if you have that much grams of calcium chloride, and if we express this in terms of mole, it's just 3.7 mole of calcium chloride. So be careful with that, okay? This produced that much. 410 grams of calcium chloride will produce 370.37 grams of chalk. But if you are given this, and we were to ask in terms of mole, how many mole of calcium chloride will there be if we have this much calcium chloride? 410.7. It will only be 3.7 moles of calcium chloride. So that's the beauty concept behind it.